Unit 5, Lesson 5, Converting from Standard to Vertex Form. So let's try and recall here the standard form. Standard form of a quadratic relation looks like this. So y equals ax squared plus bx plus c. In standard form, the only key point that we can easily see is the y-intercept. And that's the c value that you see here. Okay. To convert from standard form back to vertex form, we need to remake that x minus h squared part. And we call this algebraic process completing the square. We need to make sure we don't change the original equation, so we need to subtract the value we add to make the perfect square. Okay, so you may remember perfect square trinomials. Remember perfect squared trinomials? We said that you could have a squared plus 2a times b plus b squared equals a plus b squared. So, I want to get this bracket squared part. That's my perfect square. So think about something like this. If you have a standard form x squared plus 12x, well, this is like your a squared plus 2ab and b squared. We need our b. What's the b value, right? So we can match the a's. So a is equal to x, and we can, here's matching another a and x. And, well, I need to find the b, and I know 2 is here, so 2 times b is going to be the 12. So what's b here? So b is going to have to be, 12 divided by 2, which is 6. So b is 6. Okay, and then b squared would be 36. Okay, so if I want to complete this, I'm going to say, okay, y equals x squared plus 12x plus 36. But if I'm adding a 36 to my original equation, I'm going to balance it out by subtracting 36. With this part here, these three terms, that's a perfect square trinomial. So I can rewrite that as y equals x plus 6 squared minus 36. Why? Because I'm just following this formula that I have up here, right? Okay, so y equals x plus 6 squared minus 36. The vertex is negative 6 and negative 36. The y-intercept is 0, 0, because there's no c value. C equals 0. Okay, now how do I get this 36 without having to do this whole funny business? Well, it's pretty simple. The kind of procedure you'd follow here is you take, x squared plus 12x. You take this coefficient of your x term, 12. Take that 12, you're going to divide by 2. You divide that by 2, you get 6. And you take that number and you're going to square that number because you want a perfect square. So it's going to be 36. Then you take that 36 and you're going to add it and subtract it back into the equation. So if my equation is y equals x squared plus 12x, I'm going to add a 36 and I'm going to subtract a 36, just because doing that balances it. I don't change the equation at all in terms of its value. What I do, however, is make it so that I now have a perfect square trinomial in the first three terms there. Okay, so let's look at another one. So here's a standard form, x squared minus 14x plus 3. It's the same idea. You get minus 14, the middle coefficient of the x term. Divide that by 2, you get negative 7. Take that negative 7, and you're going to then square it. So negative 7 squared is positive 49. 7 times 7 is 49. Then you're going to rewrite your standard form as x squared minus 14x. Now, before you write that plus 3, you're going to start by writing a plus 49. and you're going to say minus 49 because you want to balance it. Then you have your plus 3. But these three terms, x squared minus 14x and 49, that's your perfect square trinomial. So you're going to factor that. Okay. So how do I factor that? Well, again, a is your x, b is your 7, because 7 times 7 is 49, and your 2ab is equal to 2 times 7 times x, which is 14x. You have a minus there, so that means you're going to write this factored form as x minus 7 squared. All right, so that's what those three terms become, x minus 7 squared. And then outside that, I have minus 49 plus 3. You're going to collect these two like terms. So my final vertex form is y equals x minus 7 squared minus 46. And so the vertex is going to be positive 7 for my h, 46 for my y, and the y-intercept is, from the standard form, y equals 3. So 0, 3. Okay, let's look at another one. X squared plus 5x minus 2. Same idea. You take that middle term 5 divided by 2. Well, you get a decimal, and I'd rather not have the decimals, so I'll just keep it as 5 over 2. So what you have to do is take that 5 over 2, you're going to square it. So 5 over 2 squared equals 25. So 5 squared is 25, 2 squared is 4, so 25 over 4. So I can rewrite my standard form as y equals x squared plus 5x plus 25 over 4 minus 25 over 4, and then your minus 2 at the end. Now, it may not be obvious, but this is a perfect square trinomial, these first three terms. How do I know? Well, break it down, right? So a is your x, because square root of x squared is x. B is going to be the square root of 25 over 4, which is equal to 5 over 2. And what's 2ab? Well, 2ab is just 2 times x times 5 over 2, which is equal to 5x. Exactly what you have in the middle. So it is a perfect square trinomial. That means I can rewrite those three terms as y equals x plus 5 over 2 squared. Then on the outside, I have minus 25 over 4 minus 2. So what's minus 25 over 4 minus 2? Well, I can rewrite the 2 as a fraction with a denominator of 4. And so that would be 8 on the top. 8 over 4 is the same thing as 2. And then I subtract those like terms. So y equals x plus 5 over 2 squared minus 33 over 4. And so the vertex becomes a fraction. The h value is negative 5 over 2. And the y value is negative 33 over 4. Y-intercept 0 and negative 2. Okay, let's look at an application problem. Cassidy's diving platform is 6 feet above the water. One of her dives can be modeled by the equation d equals x squared minus 7x plus 6, where d is her position relative to the surface of the water and x is her horizontal distance from the platform. Both distances are measured in feet. How deep did Cassidy go before coming back up to the surface? Okay, so think of a visual for this situation. We have an x and y axis. X, y. Cassidy's diving platform is 6 feet above the water. I'm calling the x-axis the water line. So this is the water. So she dives and comes back up to the surface. How deep did she go? So I want the minimum value of this parabola. So it's kind of like a parabola like that. Okay, and I could extend further, but we're not going back up like that. It's coming back up to the surface of the water. So how deep? I want the vertex. So I need to find the vertex. I need to find vertex form as one way to help me out here. So let's complete the square. So d equals x squared minus 7x plus 6. So take that 7, it's minus 7, divided by 2, and we get negative 3.5, but let's keep the fraction. So I'm going to take that fraction, I'm going to square it. So negative 7 over 2 squared is 49 over 4. So that means I can write this as d equals x squared minus 7x plus 49 over 4 minus 49 over 4 plus 6. And so these three terms make a perfect square trinomial. I can now factor them. And so my factored form will be x minus, because it's a minus 7x, so x minus 7 over 2 squared. And on the outside, I have minus 49 over 4 plus 6. So 6 can be written as a fraction, the denominator of 4. Just say 24 over 4. And then I have x minus 7 over 2 squared, and negative 49 plus 24 is negative 25 over 4. And there's my vertex form. And so the vertex is 7 over 2 and negative 25 over 4. Okay. An alternative way to get this answer is, remember the axis of symmetry formula? The axis of symmetry formula is x equals negative b over 2a. I could also have done that as well. So b is negative 7, a is the invisible 1 in front of the x squared. So I could have had negative of negative 7 over 2 times 1, which is equal to 7 over 2, exactly what we had here. And then you would substitute that into your equation to find the y value, and you'd still have negative 25 over 4. So there are a couple of ways of doing it. Whichever method gets you the answer, as long as it's correct. Okay, and that's it. That ends this video.